Hi, so I'm reviewing a bit of the math challenge, and I'm in particular looking at this problem called Cubetrails. So I don't want to go into too much detail on all the problems. I just really want to talk about part D for trails of length 4 and part A for trails of length 2. So we're going from some vertex to some other vertex, and a trail is just a sequence of edges that connects them, and you can't repeat edges. So, but you can repeat vertices. Okay, so this was the last problem in the middle primary, and if you actually look at in this year, the junior, the Cubetrails appears again, but maybe with slightly more detail and a little bit more difficulty. Okay, so the one thing I want to talk about is, so if you want to list all the different trails of length 3, oh actually no, which vertices can be reached from A with length 2 and which can be reached with length 4. So if you look at this diagram, okay, so you might be able to get the answers just by listing them all out and trying them all and not being able to do the others. But if you look at the diagram, you might wonder why the vertices are colored black and white. Okay. Not really knowing why they're colored black and white. If you do color them, you can notice that when you do color them black or white, that every black vertex must in one edge go to a white vertex. You see that? So there's no adjacent vertices that are the same color. So if a trail is of length 2, it must go to a black vertex and then back to a black. So there's no way it can get to a white vertex. And similarly, if it's a length 4, it goes to a white, a black, and then a white, and then a black, and it can't go back. So it'll end up being a black vertex. So that shows you why you can't get any of the white vertices for those two parts. And to show that you can get the black ones, I guess it's simply a matter of listing the black one, listing the trails that gives you the other black vertices. Now that's kind of neat, and the coloring of the vertices, I'm not sure if it was even intentional, or is it maybe just so you can recycle it in this problem. But that'll give you a good way to answer. I guess to answer it is fine, but it's a good way to actually convince yourself why these answers are right. So for trail of length 2, we just kind of did, and length 4. Now length 3 is also easy because you know it has to go to if it's starting from A, it has to go to a white, then a black, and then a white. So in length 3, it has to end up in a white. It can't end up in a black. And then to show that all the whites are possible, you just list the trails that demonstrates that. Okay, so that's the part of the cube problem I wanted to talk about. It's really just sort of a nice reason for why the answer is what it is. Okay, so it's a nice reason with the coloring of the vertices.